Okay, hello everyone. Today we will be talking about the Math Kangaroo 2017. And let's begin. So the first question, we got two different numbers and their greatest common divisor is 6. So their sum should also be a multiple of 6. And this is the only one that's not multiple of 6. So we pick B. And question 2, we just have this ratio and we multiply this by 2 and we get a height. And question 3, since there's three unique paths from A to B, that means there's at least 3 different paths to lead to B that we cannot stop inevitably. This is the first one, this is the second one, this is the third one. And we can also use three different bomb to destroy the path. Therefore, the minimum number of bridge we need to eliminate is 3. Question 4. So we have this and we just write it in mathematical expression and we get this equation and we just going to cancel out some terms and we get this. Question 5. So what is the probability that a natural number is not divisible by 9 is divisible by 3? So we can view this as a group of 9 and we eliminate 9 because we know that this is not divisible by 9 already. And we got 8 number left. Out of the 8, we have 2 numbers that's divisible by 3, so that's going to be the probability. Question 6. So we get a circle and we need to find the portion of shaded area. So this is very simple. We just need to find the angle, the total shaded angle, which is 120 because this is the radius and those two are equal. And it is very easy to see that those two are equilateral. So 120 degree over 360 degree is 1/3. So that's 1/3 of the area. And question 7, we just need to make sure that there's no 4 consecutive black blocks and there's no 4 consecutive white block. And A is the only one that satisfies the condition. Question 8. So since this thing have a negative slope, so this is going down, and the y-intercept is 7, which means it's about here. So it doesn't cross 3, so we put C as our answer. Question 9, so we want to maximize the probability of picking a blue ball. So what we do is we have the number of blue ball over the total number of balls, and then we first simplify the expression, and then we use a common denominator, and we have the numerator, and we compare them and pick the largest one, which is B. And question 10. So we want to find that there's the most number of intersection with the function f of x equals to x. So we just equate them together and we just need to check how many solutions are there. This one has 2, this one has a 3, this one has 1. So no, 2. So be careful that the cubics is only going to have 1 solution because this is going to share the same sign as the 1, but when you are having a square root or any power to a even number, you can have like a different sign which leads to 2 different solutions. If this is odd, there's only 1 solution. So this one has 1 solution to 2 solutions, this one has 1. So B has the most number of solutions. Question 11, so we got 3 circles and they have 3 to 1 centimeter to be their radius. And what is the area of this triangle? So after we connect these, we can get the 3 sides of this triangle. And use Pythagorean theorem, we can prove that this is a right triangle. And we just need to multiply 3 by 4 and divide by by 2, and we get the area. In question 12, so we get 5 different expressions, and we need to know which of the following is the largest. So the first one and the third one, we can be proved that first one is less than Q and the third one is less than P, because here P is less than 1 and 1 is greater than P, in other words, and this expression should be less than this, and this is equals to Q, so this is less than Q, and this one, because P is divided by a number that's greater than 1, which make it even smaller, so P, this is less than P, and D and E is just straightforward P and Q. And P plus Q as Q positive number is going to be larger than any individual element. Therefore, we pick this one. And question 13. So, we got the 2 different cylinders, right? They have the same volume. And using the volume formula for the cylinder, and we get this expression. And we substitute 1.1 radius of A to replace the radius of B, and we cancel out the common terms, and we got the ratio of HB and HA. Question 14. So if we look at our, so the currently it's 9 o'clock, and we need to know that how many full minutes will be passed until the number hand has taken over the hour hand. We know that in order for a minute hand to go the full circle, there must be a full hour to pass, and in order for an hour hand to fully turn a circle, it must be 12 hours that's passed, and that's how much the minute hand moves each minute, and this is how much the hour hand has moved each minute, because 12 hours, right? We divide the 12 hours into different 12 sections, and then we further divide an hour into 60 minutes. And we know that our hand is ahead by 3/4 of a clock, and we get this equation. And and we got T is approximately 49.09. And question 15. So we have 4 tetrahedrid. And question 15. So the only way that we cannot construct this number is that every time we just roll the same orientation of the tetrahedrid, and we just cannot use a certain number, because each time we roll we got 3 different numbers to use, and if we keep getting the 3 same number, which means one number will be left out and we cannot use it and we cannot form the 2017. Therefore, so it doesn't matter which number you roll first, and if the other 3 has the same orientation, which each individual trial is going to have the probability of 1/4, and we to the power of 3, we got 1/64 to be the possibility that we cannot construct 2017. And divide this from the total probability, which is 1, we get 63/64. And question 17. Okay, question 17. No, 16. The length of 3 different sides of a rectangular prism are 3 different roots of the equation. This cubic equation. What is the total surface area of the solid? We're just finding the root, and you just first try some random integer solutions, and you're gonna be able to factor the whole thing, and you're gonna find the side length to be 2, 3, and 4. And you're gonna get a surface area, and if you want to find the surface area, you just need to have each face and multiply by 2, which we get 52. And question 17, finally, this is the true 17. And so there's a total of 2017 chips, and 1009 is going to be black and the rest are white. And we are constructing a square pattern using this. We're gonna construct this square pattern, and if we have extra black and white, we're just going to keep expanding. So we're gonna test the square number until we run out of the chips, right? So 2017 is between the square of 44 and 45. Therefore, 44 is the largest possible square, and we know that in that square there's an equal amount of black and white. So we just subtract the total number of chips by half, and we get a number of black and white left. And question 19, so instead of looking at the side like individually, we're gonna take this as an expression as a whole. So there's 4 different right triangle, and which we already know 3 of the expression if we label the inner sides as A, B, C, D. And what we want to find is the side length of AD, which is the square root of A squared plus D squared. And this can be viewed as those 2 divided by this one. And we get this numerical expression, and we use the perfect square formula, and we rearrange it a little bit, and we get this, which is option D. Question 20 is a logic problem. If 2 and 5, the second and the fifth statement is a lie, we're gonna end up with 27 or 72, because it says one of the digit is 2 and the other is 7. But none of them satisfy the other 2 conditions that's true, which is we must have an even number, and at the same time it must be less than 30. So it cannot be happening. If the third one and the sixth one, they are the lies. And those 2 are contradicting each other, as we cannot have a number that's less than 30 and also being greater than 50 at the same time. So which it tells us that 1 and the first statement and the fourth statement must be the one that's wrong. So we have a digit to be 7, and the number is larger than 50. So we got, and that 7 must goes to the 10th digit, because it must be a even number. If this is on the unit digit, it's going to be an odd number. And we got 2 different numbers, which is divisible by 3 and 2. How do we figure out is that the other 2 statements that cannot be true, and there's a statement states that one of its digit is 2. If it is true and we pick 72, we're gonna end up with 5 statements that's saying that this is true, but that's not how it works. We cannot have 2 to be inside our digit, because this is a lie. We have already analyzed it, which means 78 is the number that we are looking for. And the question said, questions 21. So how many, wait, am I missing a problem? Oh yes, I'm missing 18. So 2 consecutive numbers are such that the sum of the digit of each number is a multiple of 7. At least how many digits does the smaller number have? So we're gonna notice the change of the digit. So if this is just a normal number and you plus 1, the sum of the digits is just going to plus 1. If the last digit is 9, you're gonna have this number here. That's going to be the change of the sum of the digit, the remainder of the change of the sum of the digits, sorry. And we just keep adding more 9s to the end of the number until we have this one. It's going to be a change that's a multiple of 7. And yeah, since this thing is not a multiple of 7, and we add the 6 at the front to make it a multiple of 7, and we plus 1, which we already discussed that the difference is a multiple of 7, and those two numbers are the smallest number, which have 5 digits. Okay. And 21, how many positive integer has the property that if you delete it, the last digit is going to be 1/14 of the original number. So this is just a mathematical expression, and since this is an integer and you multiply that by 14, so a must be a multiple of 14, and we have a equals to 14k. And the left side is equal to this, and the right side is equal to this. Since this thing, if you view this as a function, 7k over 5 is greater than k, this thing is going to grow much faster. And at one point, this thing is just going to be too big to compare with this. And we try the positive value starting from 1, and those two satisfy the condition. And those two, this number is already getting too big. So there's two numbers that satisfy the condition. And 22 is a very similar problem to the last math kangaroo, a question that showed up in the last math kangaroo contest. So we're gonna analyze each individual petal and how much is it. So we're gonna have two sectors. Let me draw this out for you. So this is going to be the first sector, and this is going to be the second sector. When we add those two areas together, the middle part is going to be counted twice, while the other part is counted once. So we're gonna divide the whole shape by once, which is the area of two equilateral triangle, and we're gonna have the middle one being still counted once because originally it is counted as twice. Okay, and we have this. Since we have 6 different petals, we multiply this result by 6 and we get a total shaded area. Question 23. So this is a sequence problem, and if you keep trying the first few values, you're gonna end up finding that these sequences end up to be in a cycle that has the period of 3. And since 2017 has the same remainder when divided by 3 as the number 1, so it is equals to 2017. And question 24, so we have a sequence of 6 numbers, and the term is obtained by summing the previous 2, and we assume that the second one is A2, and we just keep adding the expression until we get this, which is equals to 47, and we can solve the second term value. And we get we just create the sequence and add those together. We get S equals to 116. And question 25. So the sum of the length of a right angle is equals to 18, and the square of the sum of the squares of the length of the 3 sides is equals to 128. So this is what we get. We know that this is a right triangle, so a squared plus b squared equals to c squared, and we can solve the value of c, and we sub that back into the equation 1, and we get the value of a plus b, and we square that. We get a squared plus b squared plus 2ab equals to 100. And we know the value of c. We substitute into the equation number 2. We get the value of a squared plus b squared, and we cancel those two equations, and we get 2ab equals to 36. We divide that by 6. No, divided by 4, and that gives us the area of the triangle, which is 9. And question 29, no, 26. So this one, the first 3 probability of winning is very obvious, and the E is clearly less than 1/5 because he just needs to pick any of the 4 boxes out of the 5 and he won't. So this one we don't have a lot of probability to win. So D is giving him the hardest time because imagine this, he has to pick the correct box, which is 1 out of 5, and he still needs to pick a white ball from the box, and it has a black ball inside, and which means the probability of us winning is greater than 4/5. So we pick the option D. Question 27. So we know that there's a minimum range and a maximum range in which 500 lies in between based on the center number C, and we can notice that no matter what, if the C is fixed, so this is the largest sum of the square we can get, and we can also alternate the sign as all negative, subtract 12, this gives us the minimum number of the sum of the square, and which give us a maximum and a minimum bound of the value C, and we immediately left with those 2 options here. And no matter how you alternate the value of the cell, the difference is going to be a multiple of 2 because 500, and we want to get 500, which is an even number, and the difference is going to be an even number, which means the original number must be a even number. So we pick 56, and that also lies in between the range. And 28, you just try all different combinations of inequality of x and y, and that's the value of x and y when you are trying that out, because the other ones are contradicting with our initial assumption. So this is the only value pair of x and y. And question 29. So we know that for this system of equations, there's a solution pair of x and y exists, and if you try to solve it, you get this to be the value of x and y. And without the loss of generosity, you can also try to switch the value of x and y, it doesn't matter. And we can use this property, and f11 equals to f33, and I think most of the value inside the function is just the same, so we pick the same number as this, so 22. And 30, so imagine if we start with a liar, we're gonna have 2, if he is lying with like 2 liars that's on its both sides, and it's just going to keep continue that everybody is a liar. And we don't want that, as we want to maximize the number of truth teller. And imagine we start with a truth teller, which means one of them sits beside the truth teller is the truth teller, and the other is going to be a liar. And let's continue with this truth teller, since I already have a truth teller on my left. So the other must be a liar. So a liar already got a truth teller on its left. So see, I need to lie. So the other must be a truth teller. It cannot be a liar. And this is just how the sequence looks like. And since more than 1,000 people take part in the banquet, and this is the first number that's greater than 1,000 that's also divisible by 3. And we multiply that by 2, because in each group of 3 there's 2 truth teller, and we're gonna plus the number of people that are not taking part of banquet, and assuming that they are all truth teller, which gives us the maximum number of truth teller of 1,683. And thank you for watching this video, and I hope you enjoy it and learn something from it. And good luck with your math study, and yeah, see you in the next one.